Greetings, judges. I'm Justin from Team Icebreakers, and today I'm going to present overview for our project. Imagine having a perfectly sharp mind, but being trapped inside a paralyzed body, unable to speak or move. This is a devastating reality for patients with ALS and severe strokes. Today, the only way out is a medical-grade eye tracking device that costs up to 40,000 ringgit. For most families in developing nations, this creates an impossible financial wall. We believe the right to communicate should not be determined by our financial status. Our primary mission targets the SDG 10 and SDG 3 by dropping the hardware cost to zero to restore mental sovereignty. Furthermore, by empowering patients to learn and work independently, and by shifting physical medical infrastructure to sustainable AI software, Iris Flow creates a powerful ripple effect across the SDGs 4, 8, and 9. Let's look at how Iris Flow works as a zero-cost communication bridge. First, for the vision layer, we use Google Media Pipe to map 478 3D facial landmarks and track sub-millimeter eye movements in real time right on the edge. Our Gemini 1.5 flash layer acts as a neural interpreter. It expands a single water blink into a full polar intent, instantly vocalized into web speech API, while Firebase triggers a real-time caregiver alert.
I would like some water, please.
We prioritize patient dignity through three empathy-driven features. First, Gemini's predictive typing reduces physical eye muscle exertion by an incredible 80%. Second, traditional systems use stressful deadman switches that ring if a patient closes their eyes. We replace this with audio rest mode, allowing patients to safely close their eyes to rest while keeping caregivers notified. Finally, we built the panic flutter, a fail-safe mechanism where closed eyes for 2 seconds will instantly bypass rest mode to fire a high-priority SOS alert.
Thank you. To make sure Iris Flow works in the real world, we tested it with a tech lead, a caregiver, and a shock patient. Their feedback changed everything. First, constant alarms make patients feel interrupted, so we created audio rest mode, dropping anxiety by 90%. Second, visually checking if a blink word caused eye strain. We fixed this with text-to-speech audio confirmations, letting users relax their eyes immediately. Finally, spelling word by word was exhausting. By adding the Gemini predictive keyboard, patients can now autocomplete full sentences with just 2 or 3 blinks. Under the hood, Iris Flow uses a hybrid edge-to-cloud architecture. For privacy, our Edge AI runs Google Media Pipe entirely locally. This guarantees zero latency and ensures no video data even leave the device. For cloud intelligence, we've only sent lightweight text to Gemini 1.5 Flash for instance constant expansion. And for the backend, web-based real-time database sends everything instantly to our Flutter-based caregiver mobile app. Our biggest challenge was involuntary blinking. Human blinks naturally all the time, which used to cause constant false alarms. To fix this, we built a validation engine using eye aspect ratio or EAR. It mathematically filters out the noise and it automatically ignores natural blinks under 300 milliseconds and usually requires a 1000 milliseconds intentional hold to register a claim. So the result, 0 accidental inputs and 100% intentional control. Today, Iris Flow reduces eye strains by 80% and drops the hardware barrier to 0 ringgit. Looking ahead, our roadmap has 3 phases. Phase 1, focus on a full mobile port. We will deploy Iris Flow via Flutter for families who only own smartphones. Phase 2, it integrates with Google Home IoT, giving patients physical control over room lighting and temperature. Finally, Phase 3 shifts anonymized blink data to Google Cloud BigQuery, providing doctors with a clinical analytic on motor control. Conclusions, Iris Flow isn't just a web app, it is a universal lifeline. That's all for us. Thank you.